Hi, I'm Marina and welcome to FX Essential or Technical Principles, a series where we take a closer look at the technical principles behind visual effects. These are the things we use every day as VFX artists. UVs, vertex color, pivots, color space, other stuff, black boxes, magic and other technical words, but rarely stop to really understand how they work. And here in each short video, I'll try to explore one of these fundamentals, visualize it and learn to see what's really happening inside our shaders and effects. I think this is a cool idea because if you want to understand something deeply, try to explain it, and this is exactly what I'm doing. So let's make the invisible side of VFX a little bit more clear and a little bit more beautiful. I hope you will enjoy. Let's start from understanding what the UV space is and how does it work, but I'm recording this explanation for the fifth time, and I think this time this is the best way, and we will start not from the UVs. So basically, all of our textures consist of pixels. And here we have size 2048, 2048. This means that we have 2048 pixels horizontally and vertically. And if we scale, we can see the pixels if we zoom. But there are lots of pixels, so the texture is very subtle. But if we decrease the size, for example, 256 by 256, now we can see pixels better. Yes? Yes. And if we decrease it even more, we can now clearly see that all of our textures are contained from pixels, and pixel is building blocks of our texture. And this is a very small quote. And each pixel also has data, and this data, this is color, and we have black and white textures and we have RGBA textures, color textures, textures with alpha channel, and every pixel stores color. Or if this is black and white texture, each pixel also stores color, but in grayscale, so it stores only one value, but it stores it in 4 channels. Okay, it depends, but basically, black channel, black color is 0, 0, 0, all zeros, and white color is 1, 1, 1, all ones. This is the basic. And this is a quad texture. It contains 256 pixels horizontally, not 64, I'm sorry, 64 textures, pixels horizontally, 64 pixels vertically, and if we calculate, we can multiply 64 by 64, and we will understand that this texture contains now about 4,000 pixels. And pixels are like building blocks, and every texture contains of pixels, and each pixel has a bit of information, a color. Yes? Yes. And now we want to sample this texture somewhere, because we couldn't use textures itself. When we are dealing with VFX, we want mainly to sample our texture on quads. Also, we use meshes. But it's the easiest way to understand how UVs are working is on quads, or on billboards, or on plane, or on sprite. It doesn't matter how you name it. Okay, so let's go in any 3D software. I have Houdini and Blender in my second window. Yes? Yes, we have plane, and we have UVs on this plane. For now, it's not telling nothing. Here we also have plane, but here we can visualize the UVs, and if we go to the UV viewport, we can see we have the unwrapped plane, and basically UVs, this is like a bridge between texture and model, and each point on a 3D model has a corresponding point on a 2D texture, and this is like a bridge, and the texture should know how to unwrap around this model. And you can think about it like about chocolate. There is a chocolate, which is our 3D model, and there is a foil, and the foil is our texture, and foil wants to lie on our 3D model, but it should know where to lie exactly, and this is our UVs. Yes. And now we can go to the engine, and in engine I will show on Unity example. Okay. We have just a basic shader. This shader is opaque, unlit, and I only sampling the texture into base color, nothing special. Usually, when we want to sample texture, we don't use this input UVs. Usually we don't use it because this node thinks that there is this input by default, and that by default it's not modified. So if I delete this input, it works as it should work because this node is expecting this input. And this has green arrow, and UVs has 4 channels, but basically UVs has only 2 channels, X and Y, or R and G, or U and V, and we can name it as we want. It doesn't matter at all. This is just data, and we can name as we want, but usually UV space names as UV, not RG, not XY, but UV. And for me it's much easier to name U as X and V as Y, because now I understand what I'm doing, but that's just namings, nothing special. Yes, and if we put this pink arrow into this green arrow, this will convert the vector 4 into vector 2, and it will take the values we need, R and G or X and Y, but we also can do it manually. We can split the vector and to append this again into vector 2. I like doing this way because this keeps things clean. But and this is how this works in engine. But we want to understand how it's working under the hood, why the texture is sampling exactly this way. And for this we are going to dive into Photoshop. And now I will be drawing. So basically what we have UV space, and you can think about the UV space as like a coordinate system X and Y, which we had in school on math classes, and where we used to draw different parabolas, lines, you can draw line, okay, lines, and other stuff. Okay, this is a coordinate space. This is 0, this is 1, this is 1. Yes, yes. And this UV space, you can think about it as like about pixels, because if we will watch on our UV node again, and in the preview window we will see that this node has some colors. Where this node get these colors? The answer is very easy. this is the data, x and y. X we have on our horizontal axis and y on our vertical axis. Also, we can name it, we can name vectors like vector x, y, z, w if we use HLSL coding. Also, we can name it as RGBA. And code will understand us. Here we use X or R and Y or G. And now, if we will think about the UV space as about pixels, about building blocks, here we have point 0, 0. So this pixel will be black, because black color is 0, 0, 0. This this point will be black. If we think about this point, this pixel, point B, this will be 1.0, and the color of this point will be red, because red color is 1, 0, 0. We have RGB, R red, G green, B blue. If red is 1 and everything else is 0, this is red. Very basic principles. Moving further. This point, name it as C. It has 0 on X and 1 on Y, so it will be green. Because it's 1 on G, so it will be green. And moving to the next point, and this will be also the corner point, top right corner. This point will be D, and this coordinates will be 1, 1. And not coordinates, but also a color code, and 1, 1, 1 on R and 1 or on G, this will be yellow. In Photoshop, we can use like this. Not 1, but 255. Okay, and this will be yellow. And this is, and that's it. That's the core, how it works and why this quad has such colors. If we look at more closer, we can see that the point in the bottom left corner is black. That's why, and that's because the coordinate of this point is 0, 0, so the color is black. Here we have pure red in this corner. In top left corner we have pure green, and in top right corner we have pure yellow. And everything in between is the pixels like blending between these corner values. So here on this, particularly on this axis where the x value is 0, we have colors that values from if we turn HSV, and if we first of all we want to put here green, then HSV, and on this y-axis we have values from 0 to 1 in value. So this point is 0, 0, this point is 0, 1, and we are altering our value. It goes vertically. If we watch on the horizontal axis, they will be the same, but for the red color, it will be altered. I'm sorry. it will be altered in value from black to red, yes, and everything in between, this will be a combination. For example, we will take a random point here, this will be E, and let's assume it will be 0.6 on X and 0.4 on Y. If we try this color here, 0.6 and 0.4, we will have something like this. And if we color pick, .6, more or less we assume, but you can see that if we color pick, we will have the altered value, and it will be altered like in our coordinate space. If we take value from this corner, it will be more to green and less to red, and this is how the data is stored. So basically you can think about these structures as about pixels, because further it will be much easier to understand other principles based on this. And we can work with these two vectors independently. We can independently work with X axis and independently work with Y axis. It's a common practice. And that's it for this video, and in the next one we will be talking about scaling and about offsetting the textures based on this principle. I hope that this explanation was understandable, and I hope that you enjoyed it and that this was useful. Thank you, and see you in the next video.